Good afternoon, Peter Thomas from Control Specialist. Thanks very much for joining us today on this webinar that we're giving on behalf of the PAA, the Profibus Association of Australia. This is the fourth webinar in a series of 5 that we've been giving. We started off a few weeks ago talking of EMC awareness in industrial automation systems. We then started to look at PROFINET, initially from a design point of view. Last week we looked at the diagnostics aspects of PROFINET and what we needed in terms of qualifying and supporting a PROFINET network, and today we're going to look at PROFINET gateways. These are the guys that are occasionally fitted to PROFINET networks whenever there is a need to transfer data between PROFINET and some other kind of network. It might be another PROFINET network, but conversely it could quite easily be PROFIBUS DP, PROFIBUS PA, RZ, CAN bus, Ethernet IP, anything that you can think of in reality. And they're all very, very similar, as you're going to see. We're also going to look at routers and why we might want to use them in a PROFINET network. And finally, looking at IIoT gateways, where we want to transfer data that resides on our network to some other higher level system, maybe an edge server or a cloud-based server. This webinar, along with all others, is being recorded. If you haven't seen the ones before and you're interested, just drop me an email. My email is at the end of this particular webinar. Next week's is on Profibus and in particular lightning surge protectors. Not necessarily on lightning surge protection in general, but more to give you an awareness that if you are qualifying a Profibus network, these guys can cause you issues and you need to be aware of them. Anyway, we're going to just briefly show you the network that we use here, both from a demonstration and from a training point of view, and then we'll start to look at each of the gateways that we want to consider to give you an idea of what's going on. Okay, so you are now seeing the network that we've been looking at over the past couple of weeks. Basically what we have is 2 IO controllers, 2 PLCs at the top left, IO controller 1 and IO controller 2. They are ultimately going to be controlling some PROFINET devices in the racks at the bottom right, rack 1, 2 and 3, 4, 5 and 6. And rack 1 is controlling the device, sorry, IO controller 1 is controlling the devices in racks 1, 2 and 3, IO controller 2 in 4, 5 and 6. We've got a couple of switches there. And from last week and the week before, you'll realize that we can actually connect PROFINET devices up without a switch, but it's not really a good idea. And we mentioned the idea of using conformance class B switches for ongoing support and qualification. So basically, the way in which this is connected up, then we basically connect our devices to the switch. We then make a connection from the switch and we start to build up to the various devices using copper, fiber, sometimes wireless. But we're going to be talking about these guys at the top right now, the guys that we've put in here to facilitate the ability for us to connect to another network. We might be sending data to that network, we might be reading data from that network. The one thing to be remembering is that whilst PROFINET is a real-time deterministic protocol, that only applies within the context of its own subnet. In other words, between a controller and between the devices. We can't achieve that through routers and gateways. So just before we move on from here, then we're going to connect these guys at the top, and you can buy many of them. These just happen to be the ones that we've got on our demonstration rig, but there are many companies that make these kind of things, and the way in which we set them up and configure them for use within our network is very, very similar. It's a button pressing exercise beyond what you're going to see today. Over here then we did have the ability of remote access, and we're going to look at this a little bit now, whether we connect via port number 2 remotely or port number 3 locally. Then this is a completely separate subnet. Let's say call it the office LAN, and we're going to basically come in here and connect to our the router, Helmholtz router, the third one from the right. We've also got a little Raspberry Pi at the right hand side, just to show you the simplicity of setting up something to do with IIoT, and in particular one of the 2 common protocols, MQTT. So that's basically what we're going to be doing. So let's have a look now then, all on these guys at the top. Okay. So here we are. So basically then, just to remind you, there's a number of components we're going to see on a PROFINET network. We have IO controllers, PLCs to you and me. These are the guys that are controlling the communications between themselves and these IO devices. If you're from a Profibus world, you'd have called the IO controllers masters and the IO devices slaves, but that's terminology is no longer appropriate for PROFINET networks. We have switches to connect all these together, and as I've mentioned in the past and stress yet again, if we have a network with unmanaged switches, that makes the support of this network and the qualification of it very difficult. So conformance class B switches are always recommended. And then we have gateways, not always, it depends on your situation. So you may have a situation where your responsibility is to create a relatively small network on some kind of process control skid that ultimately is going to connect to an existing PROFINET network. So rather than you asking for access to their existing PLC configuration, you can create your own network based on your own IO controller, and then you can agree with the system integrator responsible for the site to link the two together. And basically there is complete isolation between the two, very, very easy to set up. But we may also have to accept the fact that there's a large number of Profibus networks out there, and there are going to be for many years to come. So we may have the need to connect to an existing Profibus network to read some data in for whatever purpose. Profibus isn't the only network out there. We've got ARSI, we've got CAN, we've got Ethernet IP. Basically, you can get gateways for almost any combination that you can think of. We're going to include in here, as I've mentioned, the idea of OPC UA and MQTT. These are protocols associated with IIoT, the Industrial Internet of Things, and the idea of getting additional data from our network-based devices to some higher level edge server or cloud server for manipulation, for basically to put the company into a competitive advantage for whatever reason. Okay, monitoring tools, not going to talk about them today. We discussed them last week. Very important for the support and qualification, because ultimately with the PROFINET network, a bus fault light on a PLC is not an indication that your network is running without problems. So always have a look at those kind of things. So let's have a look at these then. So basically gateways, couplers, routers, all the guys to connect to some other network. And basically a gateway is a physical device. It sits on a DIN rail, 24-volt supply usually, and it facilitates the communications between two industrial networks. One in this case will always be a PROFINET network. So on the PROFINET network, the device is going to appear, or the gateway is going to appear as an IO device. In other words, a multi-module analog input, digital input and output device. And because of that, then this device has to come with a GSDML file. GSDML files are critical for inclusion in a PROFINET project. And basically, you treat it like any other device. It's very, very simple to add. It needs a PROFINET name, and it also needs an IP address. They're available for a wide range, as I've mentioned, Profibus DP, Profibus PA, ARSI, CAN bus, etc., etc. Most of them are the same. Where they differ is in particular the Profibus PA, which I'll be explaining. There's a little bit more work involved in configuring those guys. If we've got PROFINET to PROFINET, then okay, they're still a gateway, but they're very often referred to as a coupler. So we'll have a look at all of these. And then aside from couplers, we've got the idea of routers for either support-based purposes or IIoT purposes. So we're going to have a look at all of these guys. There's many manufacturers here. I'm not trying to push you down any particular route. I'm only going to be able to show you the ones that we've got, but all of the big guys are there doing these kind of things. Some of these are standalone modules. Some of them are modules that sit in a PLC rack. There isn't necessarily one reason to go for one rather than the other. It doesn't really matter. But there's lots of companies out there that are doing this kind of stuff. Okay, so let's have a look then at the situation where we have our PROFINET network needs to link to an existing PROFINET network. It may be on a completely different subnet. You may not be able to have access to the PLC program for further modification. So this is what we've decided to buy then. We've bought this little guy here. Looks like a little switch, whereas in reality, you should consider a vertical line going between the left-hand pair of ports and the right-hand side ports. On the left, we've got PROFINET network A, and on the right, we've got PROFINET network B. And basically, you will need a GSDML file for each of the two hardware configurations, yours and the one on the right-hand side. And it sits like this. So here's PROFINET network 1, maybe your PROFINET network, and that happens to be in a subnet 192.168.0 with many devices on there and at least one IO controller. This IO controller project, or more specifically the hardware configuration, is now going to be increased by 1 by incorporating the GSDML file for this guy here. And he will communicate writing and reading from it as though it's just another device. In a similar way, the people responsible for the network on the right-hand side will have a similar situation. They will basically be in a different subnet, maybe even the same, it doesn't matter, but basically we've got their controllers and their devices, and their hardware configuration needs to include a new device, that being this particular gateway, and IO controller 2 will talk to the gateway and read from it. It will have no concept of the devices on the left, nor will the situation on the left have any concept to the devices on the right. He is simply talking to modules. So that's the basic principle of it. From a configuration point of view, then as I mentioned, we need a GSDML file. So here's our GSDML file with a little picture there, and we drag this into the hardware configuration. If you're not a Siemens person, it's a button pressing exercise. The process is still the same. We need to drag the GSDML file into the library and somehow bring it into our list of devices that we need to communicate with. And when we bring it in, we're asked to assign it to a particular IO controller. And then you can see in my case, I've decided to link it to IO controller number 2, and we give it a name. I'll just briefly mention the name. Very often PLCs have the ability to automatically give a name, in this case PN coupler X2, and if we had another one, it would probably be X2_1, and so on and so on. Always a good idea to try and create your own names to be application specific rather than a generic name like this. So when we drag it into the IO configuration, then again, this is being repeated on the other network as well. We have to give it a name and an IP address. They're completely separate on either side. And then we have to configure modules. Now in here, this is where it gets a little bit techie in the fact that all we have to do is define the amount of data that we want to read and write. We are not defining particular modules as such. So clearly you have to have an awareness of how much data are you transferring. In this particular case, I've decided that I want to read in 64 bytes of data in whatever format from the other side, and I'm going to write 32 bytes of data going out. Whether that's individual words, whether it's individual bytes, whether it's a floating point, it's irrelevant. I've decided I've got 32 bytes. On the other side, we've got to have exactly the same configuration, but a mirror image. So for example, if I am reading in 64 bytes, I'd expect the other guy to have an out of 64 bytes. And in the same case of this, I'm sending out 32 bytes. So I'd expect the other guy to have an in of 32 bytes. But that's about as complicated as it gets. So, okay. So let's have a look then. That's very simple. I mean, there really is nothing to it. I've done it many times myself on projects that I've worked on. It's a bit of a non-event once you've actually added them in there. Okay, PROFINET to PROFIBUS DP. So, okay, this is now slightly different where we may have, let's call it a legacy Profibus DP network. For those of you that are using Profibus on a day-to-day basis, that's still the same here in the UK. But the reality is more and more of the industry is moving over. Process control, water industry, probably still this is state of the art and will be for some time. But there is a move gradually over to industrial Ethernet, PROFINET being an example of a industrial Ethernet protocol. So, okay, we've got a little guy here, looks exactly the same, except you can see he's got a Profibus DP port, and he's also got some dip switches, because again, this guy now is going to appear as a Profibus slave on the DP side and as a PROFINET device on the PROFINET side. So very, very simple, but this time the manufacturer has got to provide us with a GSDML file for PROFINET and a GSD file for Profibus, and they get incorporated into the hardware configuration of the IO controller in the case of PROFINET and the Profibus master in the case of the Profibus DP. Because it's a slave, Profibus DP slave, it's got to have an address, and there's the dip switches that you set at the bottom. So very, very similar situation. On the left-hand side, we've got a Profibus master with a number of slaves, and where that network is now going to be increased by one extra slave, that being this particular gateway. On the PROFINET side, similar situation, IO controller with devices, and the IO configuration, hardware configuration in the IO controller is also going to be increased. We can't communicate through this device. We are communicating to registers within the device. You'll notice that this guy, like the previous one, has got LEDs to allow us to see the status of the network on that side. So we've got a bus fault light for basic communication, system fault for diagnostics, and so on and so on. So we've got a bit more work to do on here, because we need the GSDML file incorporating into the PROFINET side of things. And on the DP side, we need to do the GSD, import the GSD file. So here's our PROFINET side, in of 32, in this case, and out of 32. That might be slightly different there, but basically you'll see the difference here. In this example here, in of 32, out of 32. So let's have a look then on the Profibus side, and you'll basically see in the same slot, we've got to have them swapped over. They've got to match. These numbers here in the I's and Q's are just the input and output addresses that you would use within your PLC program. So there's no programming of these at all. It is simply you deciding how much data do you want to read from the other side and how much data do you want to write. It does not have to be the same size at all. That's basically it. Now you think, well, maybe all of them are like this, and generally, yeah, the answer is yes, they are very much like this. It's just a matter of configuring both sides. You may be only responsible for one, it doesn't matter. If you want more data, you just change the modules. Very straightforward. Some of these devices have web servers on the PROFINET side. So this is basically the built-in web server of the PROFINET to Profibus gateway. And you can see on here, we've got an indication of the LED status and the bit rate on the Profibus side, so 1.5 megabits per second. It's telling us he's connected, and we've got no issues in terms of LEDs. On the right-hand side, then this is the PROFINET, telling us our name, the name there, PROFINET to Profibus DP, his IP address, and again, no obvious issues. This is for diagnostic purposes only. There is nothing more for us to do on this particular device. PROFINET to Profibus PA. Now this is slightly different, because most gateways work on the assumption that the network that we are going to connect to has got some kind of controlling device. For example, a Profibus DP master, an ARSI master, a CAN master, etc. With PA, it's slightly different in the fact that we're going to assume that the PA devices will only be controlled by the PROFINET controller. So, and as you're aware from a Profibus device, he can only talk to one master anyway. So these gateways are assuming that we have got existing PA devices that we are now going to incorporate into our PROFINET configuration. So this is one from Softing. P&F make these kind of things, as do other companies. And from what I've seen, it's very, very similar in terms of how you configure it. So basically, at a simple level, it's going to facilitate the communications between PROFINET and Profibus PA. So basically, the thing to remember then is the gateway is now acting as a PA master on the PA side. So it's slightly different to the examples I've shown you before. And it's a little bit more time consuming because the reality is your situation in terms of the PA devices that you're going to communicate with will be different on every site that you go to. It will be application specific. So it means that in order to incorporate this into our hardware configuration, we're going to need to create an application specific GSDML file. And that means that the manufacturer of the PROFINET to PA gateway will have to give you the software to do that. And I'll briefly show you how that works. So on the left-hand side then, just an ordinary PROFINET network. And again, this device will need to be incorporated as an IO device in the same way. And on the right-hand side, we're going to connect to our PA slaves using the normal PA cabling, etc., etc. So this is the software, first of all, that we get with this guy. What you can see here is this is the process in which I am starting to create my application specific GSDML file. What I have to do here is I have to import these three on the left. I have to import the GSD file for every device I want to communicate with on the PA side. So in here, I've got a mixture between some generic PA files and also one from Anderson Hauser. It doesn't matter what order I'm importing them in, that I'm just getting them into my library. So my device catalog are the available GSDML files, not the ones I'm going to use. What I then have to do is drag from the device catalog over to the right-hand side for the segment configuration. You can see here I've dragged one of the devices from the catalog, and I'm asked to give that a Profibus PA address, in this case number 3. And I continue that process, dragging these over in the order that I want, in other words, in address order. And when I've done that, I will then create a GSDML file. There's two options in this particular case, which I won't go into in detail, but generally both of these are producing a GSDML file that is specific to this application alone. If you change anything, you're going to have to come back here and add or delete as necessary. Once we've got that GSDML file, it's just an ordinary GSDML file that gets incorporated into our PROFINET network in the same way as before, exactly the same way. So there's our GSDML file that it creates, and we bring that into our network. Very, very straightforward. And that's it. There's nothing to do. There's nothing to do now on the PA side. That device that we were looking at a minute ago, that's able to support 4 separate segments. So quite straightforward to set up. One thing to remember, or to be aware of, should I say, is that that's the current state of play with PA networks as it stands now. However, some of you might be aware of a new technology coming out. It's called the APL, which is a generic term, the Advanced Process Layer. This is going to basically bring into our arena something called PROFINET for process. And what that's going to allow us to do is it's going to allow us to have Ethernet-based devices out in the plant, where we will be able to directly connect them to our PROFINET network. It's called the Advanced Physical Layer because what it's going to do is it's going to facilitate full duplex communication. So in other words, bidirectional communication, 10 megabits over the existing PA cabling. Clearly, we'll have to have an interface at the PROFINET side of things, but fundamentally, it will be now an Ethernet-based device. So that you will have in the coming months, let's say maybe 12, 18 months, you will have a choice. You either leave the PA devices and the cabling as they are, and you use one of these PROFINET to PA gateways, or on a new project, you may basically get an Ethernet-based device for out in the plant. It's the same cabling, the same kind of cable length distances, and also it will be able to go into ATEX hazardous area applications as well. So that's coming along. It's not a PROFINET specific solution, it's an industry-wide one. And as far as I'm aware, APL is a generic term at the moment, but just keep your eye out for PROFINET for process. P&F, those guys will be aware of this, and I'm sure getting themselves ready for products to go out to the market. Okay, RSI, not really a network at the same level as Profibus and PROFINET. Generally very simple to set up. Sits lower down because it's generally designed for basic digital input, digital output devices. It is possible to do analog, but it was kind of always stretching the technology. It was always designed as a very simple, the name is there, sensor, typical little sensors. Very, very simple. We don't have device specific configuration files here because every device is capable of 4 digital in, 4 digital out. So we're limited to 31 slaves, 124 dig in, dig out per RSI network. Runs at a fixed speed, 167 kilobits per second, and we use unshielded and very often flat profile cable, and these devices literally pierce the cable wherever you want them to go, and these are still being installed. There is still some life in RSI yet, and I noticed that there is now I think it's RSI 5 that's come out, so it's going to be around for a long time. We can now, as we could with Profibus, you can incorporate this into a PROFINET network as well. This is basic, very, very high level, but the way in which we set it up is exactly the same kind of way. So basically, very similar thing. They're available as either standalone devices that sit in on a DIN rail with a separate 24-volt supply, or you can buy them as modules that plug into the PLC rack, like the guy on the right in the case of a Siemens S7-1200. So various ways of doing it. Clearly, the guy on the left and the guy in the middle, there's an LCD display there to allow us to configure the devices on the RSI side of things, but relatively straightforward. Okay. So this is basically the benefit of RSI in that they all sit on this yellow cable in any kind of topology except ring. Very, very straightforward, but very easy to incorporate. So on here then, basically, this is what we have on here. So basically the RSI device. So at the end of the day, these are PROFINET IO devices from a PROFINET point of view. And however we do it, we sit on here. The advantage with the PLC module is that you only add the devices that you want to communicate with, rather than what the top one, which is a complete RSI master capable of supporting up to 31 of these devices. But at the end of the day, it's RSI communication. IOLink, possibly a contender for the market that is being taken to date by RSI, but again associated with low-level sensors. These are very, very similar to the concept of PA in that not from an electrical point of view, but from a acyclic parameterization of the devices. The parameterization capabilities of RSI devices are quite basic, whereas with IOLink devices, they're akin to PA devices. And these are starting to come more and more popular in factory automation. It's not the similar kind of layout. It's point-to-point communications, but it's basically becoming a very common way of connecting a higher level network like Profibus and PROFINET down to these individual devices, rather than using conventional wiring from some kind of remote IO device. These guys do come with a configuration file, an IODD, and it's mainly used for acyclic access to parameterization whilst the plant is running. So as I mentioned, similar to the concept of PA. And again, number of devices available. We can get them for typically for bulkhead mounted devices with M12 connectors. We can get dedicated modules that go into a PLC rack. Again, it doesn't make any difference which one we use. The standalone devices, again, they need a GSDML file. So you can get the general picture here. At the PROFINET side, they are always appearing as an IO device, and there's a GSDML file. And in most cases, you don't have to do anything with them, with the exception of the PA that I showed you earlier. So from an IOLink point of view, then various ways of connecting. We can also mix and match conventional NPN, PNP, 24-volt supply contacts with IOLink devices. So very, very flexible, becoming very, very popular. Then we have IIoT gateways. So this is where we are not connecting to another communications network in like Profibus or RZ, anything like that. But there is an acceptance of the fact that our PROFINET network and the devices connected to it often have useful information over and above their inputs and outputs that some higher level system could maybe correlate or link with other bits of diagnostic information to build up an overall picture. It may allow us to improve quality, predict maintenance issues, etc., etc. But this data is very, very rarely the IO data between the IO controller and the gateways. It's other data. What I'm going to show you in a minute is a brief idea of what is becoming more and more popular, and that is that a lot of the PROFINET diagnostic tools are now able to send out their diagnostic data to an IIoT network, and they will do so via one of two protocols. We have MQTT and we have OPC UA, which I'll come to in a minute. In this particular case then, okay, here is a softing one. I'm not using this particular one, but basically on the left-hand side, we're going to have our PROFINET network on here, and then we've got MQTT or OPC UA sending the data to some server-based setup. The two most common protocols at the moment are OPC UA and MQTT. OPC UA and the PI, the Profibus and PROFINET International, have got a very close relationship. So most of the technical and marketing information you're going to see on the PI website will be to do with OPC UA. And this is going to be their solution for machine-to-machine communications, PLC to PLC communications, and also machine-to-cloud communications. However, what has been happening over the last probably maybe the last 6 months, 12 months, is MQTT has started to rear its head. If any of you are interested in home automation, you'll be well aware of MQTT. It's well established. And now Siemens have now started to incorporate MQTT as well as OPC UA in their PLCs off the shelf. So basically, the situation that we stand at the moment is that our network has diagnostic tools and it has PLCs that can interact with these IIoT gateways. So what I'm going to just briefly do is talk about MQTT for those of you that may not have come across this. Basically, it works on what's called a pub-sub basis, publisher-subscriber basis. And what we have is we have all of the devices connected to our network, each with a separate IP address, and this will be our this could be our PROFINET network. It could be a separate Ethernet network. Each device, each publisher publishes a particular topic, and the definition of a topic is a bank of data. It is not one tag, it is a complete stream of data. In the case of the ProCentec Atlas, which is a PROFINET diagnostic tool, if you look in their manual, they publish 3 topics, and the topics have got a particular path. The first one is /Osiris measurement Ethernet devices, and the other one the same, ending with Q factor. We can't control this, we can't change it, we can't change what we're going to get. We just got, if we want to see what we get, we subscribe to it. On the right hand side, we've got an S7, well, it says S7 1200. It is on my network. That's clearly an S7 1500. But basically, this is where we do have a little bit more control, in that we define the topic name. And the syntax is always this, /X/Y, and so on and so on. So these guys are sat publishing something to the network. We don't have to tell them all of the subscribers. All as we do is point them to a broker, and MQTT requires a broker. And in this particular case, we've just got a little Raspberry Pi, but we can buy more industrial automation suitable devices. But this is just basically a bit of software that sits on a server PC based system where it is looking for data. It's a very, very simple setup. And any publisher sends the data, usually on change, to the broker. The broker doesn't do anything with it unless we have got a subscriber. And in my particular case, I've got some software on my laptop called MQTT Box, which is just some free to download software that I can plug into my network as long as I'm in the same subnet. And what I will do is I will connect to the broker, and I will basically subscribe to the topics that I am interested in subscribing to. So let me just have a look on here for you. Just bear with me a minute while I go to the situation on here. Right, you should now see my screen, which is the interface of the MQTT box. The first thing I've got to do is connect to my broker. The setup of the broker is just within the just basically the IP address and subnet. After that, I've got to add as a subscriber. So if I click on subscriber, I then go on here, and what I have to do now is type the topic. Now, basic MQTT doesn't have a browsing interface, but if I type in, for example, that, which was one of the topics, and then I subscribe to it, then hopefully what is going to happen is after 10 seconds, we're going to see the PLC publishing a topic. And you can see here, I've got it to publish the words CSL webinar. Now, in reality, this is just a data block in my PLC program. So this could be anything. I've got it set up for publishing every 10 seconds. If you are a Siemens user, this is all available as a downloaded project that you can incorporate into your existing PLC. So this is clearly not associated with real-time communications. It's publishing some information to some higher level system. It might be an average value over a period of time, whatever you want it to be, but it is very, very simple. And the beauty of it with something like the Raspberry Pi is you can try it out on your own network before you put it to the real world. If we add the subscriber from a Ethernet point of, sorry, from an Atlas point of view, just let me remind myself of the topic itself. So here we go. So I will add another subscriber now. So we have to type Osiris measurement Ethernet devices. So on the assumption I've typed that incorrectly, I can subscribe to that, and hopefully we will find that, there we go, there's the data there. Now, this is one of the problems with MQTT, especially when we're using PLCs, because the PLCs can also act as a subscriber. In other words, read this data in. Well, if we look on the left-hand side, I'm just basically generally sending 40 characters, whereas you can see this Osiris, which has got lots of information about the diagnostics it's picking up. If I go to the bottom, that is sending 23,000 characters. what I've found is that this is very dependent on the capabilities of your PLC, the size of your program, etc. So be very, very careful before you commit. In reality, I would think that the information on the right is probably more akin to being put into a database rather than some PLC, because this is a large amount of data and I couldn't read it into my PLC at all. I had to limit the amount before I could get it to work. Okay, so that's basically where we are with MQTT. Very, very straightforward, and it's becoming more and more popular. OPCUA seems to be a bit more established in terms of the ability to browse for particular tags in a similar way that OPC has been for many, many years. Both MQTT and OPCUA have encryption and security capabilities, so worth having a look over. It's quite straightforward to set up. Now, what about the situation where we may want people to come along and set up the ability to support their network without actually plugging into the device itself? So let's have a look on here then. Here we've got a PROFINET router. Looks like some kind of gateway, but in this particular case, it is the top port is called the WAN, and the bottom 3 ports are called the LAN. And basically, first thing to be aware of, this will not facilitate real-time communications. It's primarily there to support communications to Ethernet-based devices on the PROFINET side. Well, what will they be? Well, they're going to be things like web servers and things like that. So basically, this guy has got an integrated firewall, and he's going to sit between an IT network, an office-based LAN, and the OT network, where we're basically our PROFINET network. This guy will not be incorporated in the hardware configuration. He has no GSDML file at all. Basically, we have at the bottom the PROFINET network, and at the top some IT network. And the reason for putting this in is that we would like to sit on our office network with some kind of conventional browser, Google Chrome, whatever, and we want to access diagnostic information on the PROFINET side of things without actually plugging into the PROFINET side of things. And what we're going to use is something called NAT, Network Address Translation. And at a simple level, what that is going to require is for us to identify the number of resources we would like access to, the number of web servers we would like access to, and we need some fixed IP addresses from the IT guys in the 192.168.16 range. And basically, when I'm doing the training on this, what I do is I expose the web server of every switch on our network. I expose the web server on the PLCs, and I expose the web server of the diagnostic devices. Nothing to do with the actual PLC to IO device communications. And basically what we have to do is, first of all, we go into the web interface, we define the IP address of this guy on the WAN side, so the 192.168.16, and then I define the same on the LAN side. That's the interface setup. And then we then start to look at the network address translation, and it is very straightforward. For every entry, I have to type the fixed IP address that the IT people have given me and the address that it's going to be mapped to. So in the WAN side, if I go onto a browser and I type 192.168.16.11, unknown to me, that will go through the firewall, and it will then bring back the contents of the web server sitting at 192.168.0.1. That in my case, that's the IO controller 1. And you can see I've just added all of the diagnostic facilities of my PROFINET network, and it means that I am limiting the amount of time that I need to actually physically connect to our network. Very straightforward to set up. I've said that a few times, but it really is. There's no software involved. It is just basically configuration. Mentioned this before, we provide training and all of this in terms of remote training, and I've delivered these in Australia several times. So that's basically what we do, other than being on site fixing problems. So that basically brings us to the end of the series of webinars on PROFINET. So you've now got 3 to look back on: the basic design, the diagnostics, and the gateway aspect of it. If you've got any questions now, you can put them in the chat window. I'll just bring that up so I can see it myself. If not, just drop me an email if you've ever come up with a question. You'll be getting a link to this, as I mentioned, shortly, together with a PDF copy. For those of you that are still with Profibus, you may be interested in looking out for the invitation to the last webinar that we're giving on behalf of the PAA, and that's going to be associated with using lightning surge protectors in a Profibus network. It's not really talking about lightning surge protectors per se, it's more in the difficulties that we can get when we're qualifying a network with a gateway, so with a lightning surge protector in. And I'll have our network set up with cameras to show you the response. We're going to be plugging in a Profibus analyzer, and you'll see the electrical waveforms. It's not a reason not to use the lightning surge protectors. It's just making you aware of the situation that when they're in, we can get some strange effects. And as long as you're aware of it, then that'll be fine. So that is it. I can't see any questions at the moment, so I hope, as before, it's been of some use, not been too long. We will send you the details. Thank you very much for your time. All the best. Bye-bye.